Hello friends, myself Rajendra Mahajan presenting my video on evaluation of definite integral by Laplace transform technique from the chapter of Laplace transform revised series. We take the help of definition of Laplace transform to evaluate that definite integral. We know that definition as integration from 0 to infinity of e raised to minus st into f of t as Laplace of f of t. Therefore, any integral in this form we can convert as Laplace transform of that function f of t. Therefore, once again I will repeat that definition. Integration from 0 to infinity of e raised to minus st multiplied by some function of t with respect to t as nothing but Laplace of the function f of t. Therefore, that term of e raised to minus st is important. Limit must be 0 to infinity. If such type of definite integral is there, we can easily convert it in terms of Laplace to find the value of that definite integral. For that, I am going to explain by some simple examples. Therefore, evaluate the following. Evaluate that definite integral of the following function. Number 1, integration from 0 to infinity of e raised to minus 2t into sine square t dt. This is the first example. Second, integration from 0 to infinity of e raised to 3t into t cos t dt. Then third, integration from 0 to infinity e raised to minus 4t into t square with respect to t. Fourth, integration from 0 to infinity e raised to minus t into sine square root of 3t divided by t with respect to t. Fifth, integration from 0 to infinity of e raised to minus 3t sine hyperbolic t by t dt. And the last one, integration from 0 to infinity of sine at by t with respect to t. Therefore, there are total 6 examples. Therefore, watch the video up to end for a clear understanding of all examples. Therefore, I will go one by one. First, integration from 0 to infinity of e raised to minus 2t into sine square t. Therefore, to convert it, we convert that e raised to minus 2t as e raised to minus st. We replace that term by e raised to minus st, mentioning the value of s as 2. Means when we substitute that value of s as 2, we get the original term of e raised to minus 2t. Therefore, this is the first term. First step, replacing e raised to minus 2t by e raised to minus st term into sine square t as it is. I am mentioning the value of s. Here s must be 2. And then, as per definition of Laplace transform, as it is integration from 0 to infinity of e raised to minus t into f of t as Laplace of that function. Here that function is sine square t. and then to obtain the Laplace of it, we convert it as 1 minus cos 2t by 2, equivalent result from trigonometry. 1 by 2 we take outside, Laplace of 1 as 1 by s minus Laplace of cos 2t as s upon s square plus 2 square, that is 4. And then we put s is equals to 2 in this step. At s is equals to 2, we get the required result. Therefore, 1 by 2 into 1 by 2 minus 2 upon 4 plus 4, we get 8. Therefore, simplifying it further, we get 1 by 2 into 1 by 2 minus 2 by 8 means 1 by 4. Therefore, 1 by 2 minus 1 by 4, finding LCM, we get 1 by 2 into 4 minus 2 by 8, and that's nothing but 2 by 8 means 1 by 4. Therefore, value is 1 by 8 as the required answer, or the value of that definite integral by Laplace transform technique. Then second example, evaluate integration from 0 to infinity of e raised to 3t into t cos t dt. Therefore, we have to go from right to left direction. Therefore, function must be cos t, then it is multiplied by t. Therefore, if we consider this given as I, suppose, the next step, replacing e raised to 3t by e raised to minus st. Therefore, that integral becomes integration from 0 to infinity e raised to minus st. This is the first step, into t cos t as it is with respect to t, and mentioning the value of s as minus 3. Minus of minus, we get plus 3, original term. Then nothing but the Laplace of that function t cos t. It is by definition of Laplace transform. That above step is nothing but Laplace of function t into cos t. And how to evaluate it? We have to apply the multiplication by t raised to n theorem, which I have discussed in my earlier video. And therefore, it is as per that theorem minus 1 raised to 1 d by ds of Laplace of cos t means f bar of s, and therefore sign is minus d by ds of Laplace of cos is s upon s square plus 1, and then differentiating it by quotient rule, we get minus s square plus 1, derivative of s as 1, minus s, and derivative of s square plus 1 is 2s, whole divided by the square of this term s square plus 1. Then simplifying it, we get minus s square minus 2s square, we get minus s square, and plus 1 whole divided by s square plus 1 whole square. Multiplying by minus sign, we get s square minus 1 whole divided by s square plus 1 bracket square, and then substituting s is equals to 3 in this step, put s is equals to minus 3. We get the value of I as minus 3 square, nothing but 9, minus 1 divided by minus 3 square plus 1 and bracket square. It is 9 minus 1, we get 8, and divided by 9 plus 1, that is 10, that is 100. Therefore, it is 8 by 100. as the value of that definite integral or the required answer. Then the third example, evaluate integration from 0 to infinity of e raised to minus 40 into t square. A very simple example. Therefore, calling it as I, suppose this integral as I, integration from 0 to infinity of e raised to minus 40 into t square with respect to t, then replacing e raised to minus 40 term by e raised to minus st as the first step. Made that color as blue and then replacing it by in yellow color and mention the value of s as 4. When we put it, we get the original term as e raised to minus 40 and nothing but Laplace of that function t square as per the definition of Laplace transform. This step is nothing but the Laplace of that function f of t, and here that function is t square. Therefore, it is Laplace of t square. And then applying standard result of Laplace, here power is positive integer, Laplace is n factorial means 2 factorial divided by s raised to n plus 1, 2 plus 1. We get 2 upon s cube. And then at s is equals to 4, we get the value as 2 upon 4 cube. Nothing but 2 by 64. It is 2 by 64, nothing but 1 by 32. Dividing by 2, we get value as 1 by 32. The value of this definite integral is 1 by 32. A very simple example. Then fourth, integration from 0 to infinity of e raised to minus t sine square root of 3 times t divided by t, calling as I, suppose given as I, integration from 0 to infinity of e raised to minus t sine root of 3 times t divided by t dt, then replacing that e raised to minus t as e raised to minus st into sine square root of root 3 divided by t with respect to t. Therefore, as per definition of Laplace, what is the value of s? S must be 1. So that when we put here, we get the original term of e raised to minus t. And therefore, this is Laplace of sine of square root of 3 t divided by t. And therefore, to obtain it, we take the help of the Laplace of division by t theorem. Therefore, it is nothing but s to infinity of f bar of s. F bar of s means the Laplace of that function sine of square root of 3 times t and its integration with respect to s. Integration from s to infinity, Laplace of sine is a, here root 3 divided by s square plus a square means root 3 square, and its integration with respect to s. Therefore, root 3 we take outside the integration sign as it is constant term. Integration of 1 upon s square plus a square is tan inverse of x by a. Here it is tan inverse of s by square root of 3 and divided by root of 3 and limit from s to infinity. So that root 3 cancel with that outer root 3 and then subtracting the upper and lower limit. For upper limit it becomes tan inverse of infinity and minus tan inverse of s upon root of 3. Value of tan inverse of infinity is pi by 2 minus tan inverse of s upon root 3, nothing but cot inverse of, or at s is equals to 1, we get pi by 2 minus tan inverse of 1 by root 3 as cot inverse of 1 by root 3. We can keep it as answer, or we can write down the value of this cot inverse of 1 by root 3 from the trigonometric ratios. Then fifth one, evaluate integration from 0 to infinity of e raised to minus st sin ht divided by t and with respect to t. Therefore, as per all previous example, we consider this as I, suppose e raised to minus 3t sin ht upon t with respect to t as I. The next step, replace that term of e raised to minus 3t by e raised to minus st, mentioning the value of s as 3. And as per definition, this is the Laplace of that function sin ht by t. And to find its Laplace, we take the help of the division by t theorem. Therefore, it is integration from s to infinity of f bar of s. F bar of s means the Laplace of that function sin ht, integration with respect to s. Therefore, s to infinity, Laplace of sin ht, standard result 1 upon s square minus 1, and its integration with respect to s. Standard result of integration, it is 1 by 2 log of s minus 1 upon s plus 1 at s is equals to 3. Therefore, 1 by 2 log of 3 minus 1 upon 3 plus 1, 1 by 2 log of 2 upon 4, two by 4 means 1 by 2. Therefore, it is square root of 1 by 4. Therefore, square root of 1 is 1. It is log of 1 by root of 2. Log a by b is nothing but log a minus log b. Therefore, it is log 1 minus log of root 2. Value of log 1 is 0 and minus log root 2. Therefore, value is minus log of root 2 as answer. And then last example, evaluate sin at by t dt. This result we require in the chapter of Fourier transform. Therefore, prepare this example very well. We call this as I, suppose that integral as I. Here there is no term of e raised to, therefore we include that term as e raised to minus st, though it is not there, and mentioning the value of s as 0. E raised to 0 we get 1, means the original term we get. And then as per definition, it is nothing but the Laplace of that function. Therefore, function is here sin at by t. Therefore, we have to obtain the Laplace of sin at by t. Then, using that division by t theorem, it is integration from s to infinity of f bar of s. F bar of s means the Laplace of sin at and its integration with respect to s. Therefore, integration from s to infinity of 1 upon, or sorry, it is a upon s square plus a square, and its integration with respect to s. A we take outside. Integration of 1 upon s square plus a square is tan inverse of s by a, and whole divided by a, limit from s to infinity. A get cancel, and we put the limits. Upper limit as infinity, that term becomes tan inverse of infinity, and minus tan inverse of s by a for the lower limit. Tan inverse of infinity is pi by 2, and at s is equals to 0, that second term becomes tan inverse of 0. The value of tan inverse of 0 is 0, and therefore value of that integral is pi by 2. The same example we have to perform in a way to take the help of this example in Fourier transform. Please like my video, share it, as well as subscribe to my channel and press the bell icon to receive the notification, as well as hype my video. Thank you. Thanks for watching.